Okay, so we were discussing about our dengue case prediction project, and we have performed the entire pre processing of our data and identified that which features were not important. So we have dropped those features also, and only the labels column was present with me, that is like categorical in nature, which is having only one category, normal. So still I am keeping it under the consideration. It may happen that if we are dealing with any other data, labels may be present, so just keep it, don't drop. I'm creating dummies at the moment, and these features I have dropped because they are correlated features. Reminder that our target is case prediction, dengue case prediction. Okay, if this is the temperature, this is the humidity, this is the precipitation, and these are the certain environmental features, what is the chance that you are going to have a dengue? How many cases of dengue may occur? Okay, fine. So that's what we are having. This is my data frame. I kept snow and snow depth also, though they are having zero values. But still, let it be. They are environmental factors. They don't have direct, so maybe indirect relationship. Anyhow, for the dengue disease. Okay. So I use standard scalar because you know that the algorithms like SVM require standard scalar. So I imported standard scalar. Okay, and whatever be my continuous features are, I applied scaling over it. Only the continuous features will be applicable for scaling. We are not applying scaling on the discrete features. Okay, so continuous features. Fine. I scaled them, and then I dropped cases from X and put it on Y. I performed train test split and used support vector regression. Mean square error, mean absolute error, R2 score, all the evaluation criteria I applied and fit my model into SVR. Okay, so once my model got trained, I asked for prediction and checked the scores. I am getting mean square error as 0.529. That's not a big error. 0.529 is an affordable error. Okay. Then I calculated RMSC also by taking the square root of MSC. I came to be it as 0.727. See, if your MSC is less, then there is no sense of calculating RMSC. I am just showing you from my side. It is not at all mandatory to calculate RMSC. If your MSC is more, then we can try for RMSC, that what its result is. But if your MSC is less, then there is no sense to calculate RMSC. But still I am calculating, and I calculated MAE and R2 also, mean absolute error and R2 score. Mean absolute error is also like zero point 0.5, that is just like MSC only. So there is not much difference. So if MSC is less, there is no need to print RMSC and MAE. This could be a question asked to you. This could be a question asked. What is the evaluation major evaluation criteria? The main evaluation criteria is MSE. If MSC is more, then only you go for MAE, else don't go. And R2 is just various explained. It is not a parameter to define a model as the best model? No. R2 just tells about the variance explained. That means how much X factors, features are responsible in predicting the value of Y. That's it. If you are having high R2, still don't think that your model is good. No. Our main criteria is MSE, error. Okay. R2 value between 0 to 1 is there. That means the features are, if the value of R2 is 1, that means features are contributing in the development, in predicting the value of Y. But Y, what value predicted? Is it matching the target or not? That can only be found by MSC. So remember, here my SVM is showing good results. Okay, I tried with disentry regressor also. With disentry regressor, the error is coming 1.18. Here the error is a bit big, 1.18. Not so much, but it is. I calculated root also, it is 1.08. I calculated MAE, so if the error is more, you can go ahead with MAE. R2 negative. R2 negative means features are not helping in finding the variance. R2 negative means this only. Features are not contributing to find the value of YP. Okay. So there are certain theories based upon it. Your model got failed. I'm not saying that model is entirely failed. This is regression. We are trying to find the target. This is decision tree model. Decision tree model doesn't tell us that the relationship between X and Y is to be like this and this. No. The approach of decision tree is to divide the data and divide the data and divide the data. This is how decision tree do. However, I am not finding any appropriate feature with the help of which I can get the Y. That is why negative. R2 is coming. You may be asked a question. Do we have negative R2? Yes. It may happen that you can get negative R2 also. And obviously, error is also more. That means my dysentery is not performing as well as SVM did. Then I applied random forest also. Random forest, yeah, it gave 0.51, that is less. Okay, MSC is less in random forest. Okay, and M RMSC is 0.72. Okay, R2 generally ranges between 0 to 1. Yes, Pawan, absolutely right. It ranges between 0 to 1. Okay, but we can get negative value. And negative value means the things went wrong. Okay, fine. Then this is RMSC and I'm getting R2.42. That means 42% of variance is explained. That means my features, X features are explaining Y. Okay, they're 42% they are contributing in getting the value of Y. We have used regression analysis over it for the prediction, and 42% of the feature according to random forest algorithm they are explaining why, what could be a value of y, how to achieve the value of y, they are explaining. This is what R2 means. I applied XGBoost also, XGB regressor, this algorithm also, boosting algorithm. I put the data inside it and trained my model, performed the prediction. Here error is a bit more, 0.63 than random forest. RMSC is again more 0.799. No need to calculate this because error zero point 0.6 is not a big deal. MAE is 0.59. Okay. See, if you are having MSC as 0.63, MAE is 0.59, they don't have too much difference. So there is no sense to print MAE here. Neither RMSC, neither MAE. If MSC is less, ignore. You can print R2 to check how much variance is explained. So 29% only. That means according to boosting algorithm, 29% of the variance is explained. These are the results which I got from machine learning model. Okay. Then I thought to apply deep learning also. I use sequential model, dense layer. I converted normal into integer type, and then I gave into my deep learning model for training purpose. Okay, so 512 neuron, 256, 120. This is how the neurons I took. It's up to you. You can change the architecture. No need to make this bulky architecture. You can reduce. I took activation function linear at the last because cases will be positive, not negative. So ReLU is possible there. ReLU is possible there. I could have used ReLU here, but I use linear. Just in case I am looking forward that okay, it's a regression problem, na. So regression, I am taking deep learning framework, deep learning architecture. So linear means wx plus b. So whatever be the x as an input will be multiplied by the weight and added by the bias. So just follow linear equation wx plus b. ReLU is non-linear. If any value less than 0, if we give it into ReLU, answer is 0. So the cases will be either 0, cases will not be negative. I could have used ReLU here, not an issue. You can change from your side. I just put linear. I think at that particular time linear came into my mind and I put. You can check by ReLU also. Okay, rectified linear unit, non-linear activation function. Okay, I compiled my model. Understand, here loss is MSC. When I was doing classification problem, the loss was categorical cross entropy, binary categorical cross entropy, sparse categorical cross entropy. But when you are doing linear, when you are doing regression problem, the loss is MSC, mean square error. Your evaluation will also be MSC, mean square error. I summarize my model. I train my model with 20 iterations. And in the training, I got MSC as 0.59 and R2 as 0.34. This is also a good model. Deep learning is also a good model for this. Not an issue. Okay. You can make plot for MSC also. I think I forget to make a plot. You can make history plot also. Here is history. Now you can make a plot for MSC between training and the validation errors. I forgot. Maybe you can include. I have already given the code. You can refer to the previous code. And then one traditional algorithm which is left. You might be thinking, sir, you haven't applied linear regression, sir. You applied SVR, you applied DTR, you applied random forest, you applied XGBoost. Every algorithm you applied, but not linear regression, sir. Why not? Why not linear regression? So I think okay. See, I have scaled my data. So I thought that whatever be the features which can accept the scaled data, let's try for them first. Linear regression doesn't say I require scale data. Scaling is also a kind of transformation. Linear regression expect that the continuous feature should have to be normally distributed. So if your scaling can anyhow show such kind of distribution, then it is okay. If it is not showing such kind of distribution, then trouble. So it's better kindly do follow, kindly do follow the transformation or the requirements for linear regression. So what I did, whatever be the continuous features are, first I need to take care that they should not be negative. They should not be zero because I need to apply log transformation over it. So if I put any zero value or negative value inside the log, that will become infinity. So the above code is just like that. If you are having a minimum value, okay, if you are having zero or less than zero, then apply some kind of maths over it. This is a maths which I apply to make it positive. And then I applied log. In previous code also, in previous project also, I did use some different kind of way and approach to convert negative to positive. Kindly refer to that also, and this is a new one. Anyhow, you can apply any approach which is coming in your mind to make the things positive. Either you can take absolute value of it and subtract the same value from and add one. Something you can do from your side. Okay, so I applied log transformation over continuous and then I dropped the cases. I took cases on y axis, I trained test split, I used a linear regression, and this is what I got. Error is 0.13. See, the lowest of the lowest error I got 0.13. Rest all were showing zero point 0.5, zero point 0.6, but in linear regression I got 0.13. Therefore, linear regression is the best algorithm which can be used to predict the dengue cases. R2, 31% of the variance explained, but R2 is not the only parameter to decide that my model is good. MSC is a parameter which can decide my model is good. R2 is an optional case. Okay, so don't rely on R2. Sir, R2 here is 31, there R2 was zero point 0.4, so sir R2 is less sir. होने दो, क्या फर्क पड़ रहा है? नेगेटिव तो नहीं है ना, इट्स नॉट नेगेटिव ना, इट्स पॉजिटिव ना. Okay, negative means opposite direction. We are searching for point somewhere, we are getting the point somewhere. Here R2 is 0.31, okay, error is very less, fine. My linear regression is the best model for prediction. Okay, so it's not only that I put my model, I am explaining why. See, it's not like that. See, code is already available with you. You guys are pretty much expert, you understand the terminologies. The thing is, I want to, in this project, now I want to brush up the concepts, what you already know. And if you have error, you can raise your question, no worry. Okay, the project means to brush up the concepts where you are lacking, and you can add these things into your, as per your knowledge, expertise, and you can work on the projects. Okay, and one more thing I did told in my current classes also. I took two classes prior to this, and I told that it's not that you are completing YouTube tutorials, completing YouTube channel, his channel, her channel. I know that her channel is famous, his channel is also famous. So you are okay. They are teaching, you are making notes, you are listening, but the question is, are you able to apply? When, why, what? The question should be in your mind. If this thing happens, then why this not? If I use that, what should the answer I get? So why it is happening? What will happen when I'm going to apply any other value, formula, and why if this is happening, then why this is happening? I should know. This is my duty to know. If you have this capability, then you can be working as a data scientist person. This will help you to learn more about the data. Okay. See, I was teaching on white sheet and you guys were kept silent because you are unable to see what I wrote there. Actually, I wrote here. I wrote here. Okay, Christmas. Knowledge isn't power until it's applied. Yes, absolutely. Application is very much important. So someone who teach you application, try to connect that with that person. Application. Telling concepts, telling concepts, okay, fine. It's the first step to learn, but application is very much important. So that's what I told here in the project. Now you did apply so many algorithms. Okay, why I use scaling, on which algorithms I should use scaling, what it will give, why not on other? Does it, if I apply standard scalar or linear regression, does it give me the proper result? Okay, try. Don't apply transformation. Don't apply the transformation which I did. Apply linear regression without applying transformation. Okay, but at least understand what kind of equation linear regression is. Does scaling is required for it or not? So every model, every algorithm is having expectation. We have to follow those expectation. Then only we'll get the result. Else will not get the result. और ये अभी तो ठीक है मशीन लर्निंग है. डीप लर्निंग में यू हैव टू बिल्ड द आर्किटेक्चर. जनरेटिव है आर्किटेक्चर. And in one of the class में Gen AI में it took me 7 to 8 hours to teach transformer architecture. Today only I finished the transformer. Today only. Am I right, Devesh?
Yes, sir.
ओके 8 घंटे लग गए सिर्फ ट्रांसफॉर्मर आर्किटेक्चर को समझाने में. वी हैव टू गो मच मोर डेप्थ इन दैट कि एनकोडर क्या है, डिकोडर क्या है, व्हाट दे डू, व्हाट दे परफॉर्म, हाउ द डेटा इज कमिंग, हाउ द डेटा इज आउटपुटेड. देर आर मेनी थिंग्स प्रेजेंट देयर. So exploration you have to do. Fine. And then I have been asked about, sir, can we do talk about some time series also? So I included some notes related to time series because our project at 5 is over. Okay, so I included time series to have a discussion. See, time series, I think it's like trend analysis. See, data can be like what you have seen so far, without a date or with date. Without date data is a general data where you have recorded some facts, some values for analysis. Date data is a regular data that has been taken on the basis of some interval, some time. It can be considered on a daily basis, on a weekly basis, on a monthly basis. Depends. Because there are certain data which change frequently. Why? There is a data which can change frequently. And the data which doesn't change frequently, we don't consider a date in them. But a data which changes frequently, in that case we have to consider the time series, trend analysis. For example, stock prices frequently. Today is different, tomorrow is different, previously was different. Time series. Weather. Weather is different today, tomorrow Next day, who knows? Finance. Such kind of problems, supply chain, obviously in sales. So those people who work in the industry, time series, they got the data in this way only. Time series, date वाला मिलता है उन्हें. Okay, so we need to forecast, predict the future on the basis of historical data to find the pattern. Okay, we need to identify the anomaly in the data. We need to identify the outlier in the data. Okay, the application of time series is in many cases I did told finance, maybe healthcare, marketing, environmental science. And the types of data which are suitable for the time series are temporal data. What is temporal data? See, that means univariate time series. That means that consists of a single series of observation recorded sequentially over time. For example, daily stock prices for daily closing prices of Apple. Daily stock prices like closing prices for Apple stock over a past year. Monthly rainfall measurement, that is temporary data. Hourly electricity consumption. So this is univariate. Okay, this is univariate data. Okay, it comes under temporal. Temporary, it's not fixed. See how we can say time series data is fixed. No, it's not fixed. It will keep on changing. It's not in your control. It is in control of time, not you. That is why we are considering time as a parameter, a reference level. Multivariate also we can have, where we are having so many features. Okay, like GDP growth, inflation rate, unemployment over the past 20 years, daily stock prices of major companies like Apple, Microsoft, Google over last month, which may have opening price, closing price, volume. There could be many features present in them. See, one feature univariate, multiple feature multivariate. We do have seasonal data also. Seasonal. So this is called a seasonality analysis. Seasonality. Seasonal data means seasonality. Okay, for example, we do have a winter season, summer season, rainy season, which comes after every four months. Seasonality data. That means you know you may have a season spikes during holiday seasons like Christmas, back to school periods. Okay, so season. We are having tourist seasons also. So that is seasonality. That means cycle that repeats after some interval, 4 months, 3 months, something like that. Trend is you have to see the variation in the data over a period of time. That is called as a trend, variation in the data. Okay, over a period of time. That could be a temperature trend, carbon dioxide levels, population growth. We may have irregular data also that displays the fluctuations that are not predictable, they do not flow a regular pattern. So, for example, currency exchange rate, euro, dollar, economic news, market sentiment, irregular. Okay. So each type of data requires different modeling techniques and approaches in the time series. We can have seasonal decomposition also, like seasonal adjustment. That's what we do. So, how to perform time series? That's the question. How to perform the time series? As like we do in the basic projects, we perform visualization here also. We do perform exploration here also. Plotting the time series to observe the trends, seasonality, irregularities, we do that. We check for stationary in the data, stationarity testing. That means it is a statistical technique, property of the time, to check whether the series remains constant over a time or not, which is often a prerequisite for many forecasting model, many. We need to check stationary of the data for a period of time. Then only we can apply algorithm, else we cannot apply algorithm. For example, Arima, Sarima, these all autoregressive Arima, various statistical and machine learning methods like Arima, exponential smoothing, LSTM, all these are time series models which we can apply. We can evaluate MAE, MS, just what we did right now. It's not classification, still it comes under a category of regression, but it is time based. Okay. So time series plotting, we can make line plot, we can make scatter plot. On x-axis, you can take time. Y-axis, you can take any feature and check how it is going, how it is behaving. Time series. We can look out for the trends in the data, increasing, decreasing, fluctuation. Okay, seasonality analysis we can do. That is a recurrence of a certain pattern. Okay, after 3 months, it will again repeat. After 3 months, it will again repeat. After 3 months, it will again repeat. Seasonality. This is seasonality. We can decompose separate time series into season, trend, and residual component. That's what we can do by performing additive and multiplicative decomposition. We can add and we can multiply also. Both we can do. Either we can add these components or either we can multiply these components. That is called a seasonal decomposition. We can detect outliers in the data, anomalies in the data by applying statistical techniques like Z-score, moving average, machine learning algorithm. Like we can do that. Okay, we can find mean, median, variance, autocorrelation. That is measure how each data point is correlated with the previous one. See, that's what the theme of time series autocorrelation. See, today is X. On a previous day, if it was X minus 1, on the previous day, if it was X minus 2, if someone asks you what will be the next one, you can say X plus 1. Because today is X, one is reduced in the previous day, one is further reduced in the previous day, that means there is a 1 1 gap. So autocorrelation means to find the correlation between the current point and the previous point. That is cyclic pattern. ये cycle ही बनाई ना मैंने, साइक्लिक पैटर्न है वो, यही ऑटो कोरिलेशन होता है. दिस इज एडिटिव डिकम्पोजिशन, ट्रेंड प्लस सीजनैलिटी प्लस रेसिडुअल, मल्टीप्लीकेशन में इन तीनों को मल्टीप्लाई कर दो. This is how you can decompose, divide your time series in this way. Visualization tools you can have use Matplotlib, Seaborn, Plotly, there are many things. If you are available with the monthly sales data, retail store for 5 years, you can plot sales versus time, all these things you can decompose it. Okay, and you can identify the outliers, irregularities in the data. That's what you can do. You can check for the stationary whether my time series is stationary or not. For that, see, it is important. A stationary time series is one where mean, variance, and autocorrelation do not change over time. These are the parameters, these are the factors which should not change over a period of time. Then only I can say that my time series is stationary, as it is not. Because in non stationary, there will be change. Okay, and it becomes difficult for a model to accurately predict the patterns in the data. Okay, so we can have the check, and for check we will be doing the ADF test, Ed Fuller test, and its value should be like less than zero point 0.5. Then it is stationary, else it is not stationary. Something p value is there. I hope you have applied. So there are statistical tests. ये रहा. Augmented Dickey F. Ed Fuller test determines if a unit root present in a data which is not stationary. Null hypothesis is called as a unit root or non-stationary. Alternate hypothesis means your time series is stationary. 0.05 is the threshold value. So if the statistic value is less than the critical, less than 0.05, then null hypothesis reject, and we will say that it is stationary, else it is not stationary. Unless and until your time series is not stationary, please do not apply any model to predict. No, बिकॉज वो जब वो स्टेशनरी ही नहीं है तो भाई तुम प्रिडिक्शन कैसे करवा लोगे उससे. If it is not stationary, how you can make a model to predict? Things are continuously changing. We expect your data to be stationary for a specific period of time. That is an internal process of the statistical measure, statistical algorithm, where your mean variance should not change. So it's saying that alternative hypothesis will be accepted if you reject the null in case the value of test is less than critical. Okay, critical is zero point zero 0.05. If your value is less, then accept the alternate hypothesis. It is stationary. If the test static is less than the critical value at a chosen significance, reject the null hypothesis and accept. There are other algorithms also which we don't miss. I haven't personally used this KPSS. I don't use this thing. Transformations, box Cox transformation. I think I haven't applied that too much in my projects. I did apply the ADF to check the stationary, and then I proceeded ahead for my model development. That is ARIMA, one of the famous name which you have heard, ARIMA, ARIMAX, auto-regressive integrated moving average. Auto-regressive, I just told you, auto-regressive. That means if this is today, what will be tomorrow? And I taught in transformer also, transformer architecture. There is one component decoder in it that is auto-regressive. Auto-regressive means my model do have knowledge about the previous. It is having a knowledge about previous. Now I want my model to use this knowledge to predict the next. That is called as auto-regressive. Okay. So ARIMA, exponential smoothing also. That is exponential moving average. We do use this technique also. Very important. Very important. We do apply this EMA in deep learning while studying the concept of optimizers. Exponential moving average. Okay, exponential moving average helps us in identifying the current trend by reducing the impact of older trends. That is what EMA do. So EMA we do apply in deep learning optimizers like Adam, and there are many optimizers there in deep learning. So which maths, which formula, which concept is applicable in other also? What is the what does it do? What is the significance of EMA? You know the maths, you know metrics, you know matrix transformation. The question is where you can apply. What does the research says? If you are not having a research mind, I'm sorry, this field is not suitable. Again, if you are learning from history or her YouTube channel, nothing will gonna happen unless and until you don't have the research mind. Okay, you learned this concept EMA. If a problem comes to you, you have to see, I have learned this thing, this thing, this thing, this thing, this thing, this thing, this thing. Which one can I apply to solve this problem? That's what help you to get something new. Else it's a wastage of time. Okay, there are many algorithms: vector auto regression, seasonal auto regression. There are many kind of algorithms: wavelet transform, Verma. See, I have used RNN, LSTM, ARIMA, not everything. Profit, that is developed, this algorithm developed by Facebook, suitable for time series with strong seasonal effects. There are many algorithms present for time series. Okay, we can use machine learning algorithms also. We can evaluate on the basis of these RMSC, MAE, these things we can be used to evaluate. Okay, and I do have another notes also based upon the time series. Okay, For- and here I have used some coding section also. Some code also I included. So I already told time series, trend analysis, seasonality detection, cycles, forecasting. That's what we do in time series. Okay, and the famous model which I use major is ARIMA, well-known statistical model, auto-regressive differencing moving average. It's a full form. Auto-regressive differencing moving average. So auto-regressive means dependent between an observation and a number of lagged observation. Lags. So we do calculate lag here. What is a lag? I guess I think this is a pretty much clear point. You are having a feature x. You are x1 and x2. This is 2, 5, 10. If I say I will be working on x2 with a lag, 2 lag of 2, lag of 2. So I will keep these two empty, and then I will start writing from here: 2, 5, 10, 11, 12. So this will be 11, 12. I gave a lag of 2. For x1, I gave a lag of 2 and created new feature with the lag. We do perform this thing. And the goal of the approach is to, okay, to find the relationship between, because this is auto regressive now. So how previous is impacting the current, how they are related to each other. That is what auto regressive is. That is why we performed lag here. We can, it depends, we can have a weekly lag, we can have a 3-day lag, depends what kind of problem you are facing. Okay, so we find the difference also, differencing the raw observation to make the time series stationary. Difference, see, you apply ADF test. If you fail in the test, then you have to find the difference, then again apply ADF test. If you again fail, again do the difference. This will be seen in the projects, and obviously moving average. So here is certainly a part of code. For example, we take all these libraries: pandas, numpy, matplotlib, arima, from stats model. We are going to take the arima. Then we can have auto correlation, we can have partial auto correlation. These are the features. We take our time series data, we convert our time series data, that's having a date, and we put the date into index. This is the first and the foremost thing. Convert date into datetime format and put it on the index side, and then visualize the plot. perform the plot for time series. Feature versus time. Take feature and take time here and draw the plot. Time is present on index position. The feature is obviously a column. Then ensure then ensure whether your time series is stationary or not. Stationary means mean variance and autocorrelation do not change over time. So there should be some time, some duration, some interval where the mean and variance should not change. If it is changing, then it's an impact. So ARIMA can be used for this thing to identify the linear trends and the seasonal trends. There is a parameter, differencing parameter in ARIMA, D. If D equal to 1, the model will use the first difference. And if the value of probability, p value, it is less than 0.05, then only your series is stationary, as it is not stationary. If it is not stationary, again perform differentiation. Difference. Still it is not stationary, again perform the difference. You have to continue the difference. This is how you perform ADF test, add Fuller test. So take your feature, put it into ADF, get the result, get the p value. We do have ACF and PACF to identify potential of P and Q. There are two things, P and Q, two parameters as I told. P and Q, P component, Q component. ACF, that is autocorrelation, shows the correlation of time series with its own lagged values. Its values means, what are the lag values? If I say x minus 2, x minus 1, x and x plus 1, what are the lag value of x plus 1 is x. Lag value of x minus 1 is x minus 2, and for x it is x minus 1. These are the lag. Now it depends how much lags you are taking. 1 lag, 2 lag, 3 lag, how much lags you are taking. So that is ACF, autocorrelation. Partial autocorrelation is also correlation with its lag values, controlling the values of the intermediate lags used to identify autoregressive component P. Controlling the values of the intermediate lags. There is intermediate lags. So we are here trying to identify partial, not complete. Complete is autocorrelation. This is we are identifying partial autocorrelation. You can make a plot by using this. Then you will understand. Huh. Here we are applying ARIMA model, time series model. We can take the value of PDQ, and the value of PDQ lies between these range 0 to 5, 0 to 2, 0 to 5. We need to find the best combination. Though I haven't tried for something like best, I do put random. Let me tell you frankly. These are the triplets. Sometimes I put 1 1 1 and I train my ARIMA model. Sometime if I'm not getting the correct time series, the predictions, then I try 1 0 1. Something I do try from my side to check. Here you okay, here PDQ, this iteration tool will generate different combinations, and you can try different combinations. I also don't know, so I try from my side. Here it is giving a code for you to try the different combination of PDQ and put it into ARIMA. Okay, put them into ARIMA. So this is a additional code which you are getting. I haven't followed this code so far, but I will look into it. This is a way to find the best suitable values of PDQ. Okay, you had to put whatever be the best values you got, you have to put them into ARIMA. Okay, you can plot your model, you can forecast. You can see the for example, n periods 30, number of periods to forecast 30. So give your number of periods 30. I need to forecast for that. So just plot between original and forecast. That's what you can do. You can perform the forecasting. Okay, between original and the forecasted value. Okay, so there are different ways of coding here. You can incorporate. Here I told that n periods model dot forecast 30 steps equal to 30. I need 30 values to forecast. It will do that. So I'll put my data, that will be original data. I will put my forecasted data. So this might be your original data. This might be your forecasted. It may overlap, it may not. We can find the next prediction also. For the next prediction, there is some smart move to be done. The smart move will be you need to find the last index of your data. That will be index minus 1, colon minus 1, something like that. You have to find it. Find the last index. And from what is the last index, you have to predict. For example, if the question is given to you, predict the future 10 values, future 10 trends. So you have you got the last index by minus 1. The next 10 prediction will be from this index, add 10. Okay, so index minus 1 plus 1. These are the next till 10. So this thing you have to take care, because the people do ask the question how to find the next 10 values, because we need to add the prediction in our time series plot. Sir, ye to ban gaya, this is done, I need to add the future trends. How to add? You need to find what is the last index, and you have to start the next from the last up till the range you have been asked for. Try to look out for that logic. I have given you suggestion. I have done a lot of projects based upon it. Okay, using arima I haven't used, there are rest other models also like Prophet and all these things I do available with the code. Okay, this is Facebook Meta XGBoost regression algorithms are also there. I use machine learning algorithms, and I have used Arima mostly. Okay, if I do talk about, okay, stock price prediction, I have done a lot of projects based upon this thing, but not recently. Okay, it was a bit like a duration has been happened. Okay, long duration. I took live sessions only. Yeah, here it is. Okay, stock market prediction. Okay, it can be like Amazon price prediction. Okay, let me talk that also. Okay, so I do have the projects. Okay, you can, if you come across like Amazon, so please let me know. I'll show you any price prediction, something like that. I am having a wide variety range of projects, a huge database of projects, sleep pattern. Okay, all right. So fine. Time series analysis pollutants. Okay, let me check this thing. What kind of project it is? Okay, I'm available with a year. Okay, not specific data. Sales forecasting. Okay, let me check this thing. Okay, I think it's a huge code. So I am available with many things I can share with you. Yeah, here it is. Here it is. Amazon, Yahoo, JP Morgan Chase. Okay, we should try for this particular code. Okay, this is sales forecasting. Okay, let's check this company. Amazon, Yahoo, JP Morgan. I did live project session on these data. Here it is. Such kind of data in stock price you will be getting open price, high price, low price, close price, adjusted close, and volume. Like this will be the date in time series 3 1 2004 1 2005 1 2006 1 2007 daily data. Then what you have to do is again set index date. Okay, now these are the features. All right, then you can filter, you can keep only close as a target. Okay, that's what you can do. Then you can use stats model, you can decompose your feature into trend, seasonal, and residual. This is how you can do that. See, the plot is looking like this because I use Plotly as a library. This is a very good code. Those people who are requesting me to uh, have the time series explanation, they can take this code from me and they can apply on their data. Here I am applying ADF test to check the stationarity of the time series. I got negative value, which is less than 0.05. So, and this is the p value. Okay, I got minus 0.485. This is test static. The p value is zero point 0.8. P value is more than 0.05. So this is not stationary. If this is not stationary, you have to find the close difference. Again, differentiate. Arimana, AR is autoregressive. I means difference. So from close only, you have to differentiate difference. Okay, that's what you have to do. Okay, how to calculate the difference? See, if you are having the values like in close, you are having value 10, 12, 13, 14. If I say difference close, so okay, इसकी previous value, this previous value I don't have anything. इसमें से इसको माइनस करना है 12 minus 10 2, 13 minus 12 1, this minus this, something like that. Difference. You have to calculate the difference. And then you have to again put it into the ADF test. Now it is 1.31. Okay. Then again I found some features: simple moving average, cumulative moving average, exponential moving average. I found it. Okay, and I plotted them. Okay, these are the moving averages. I plotted them. I plotted ACF, PACF also. Auto correlation function, partial auto correlation function. I plotted. Okay, and then after doing all these things, all such plots, I need to look out. Here I applied ARIMA. Once my values get stationary, then you can apply ARIMA. ARIMA, you can have any combination P, D, Q. I took 1 1 0. I can take 1 1 1 and check where my model is giving the good prediction. Okay, I trained my model with ARIMA, and here I ask for prediction. Start 0 till the entire end of my data. Give the prediction for it. So it gave me a prediction. These are the ARIMA predictions. After getting the predictions, I plotted actual versus predicted. I plotted. Okay. All everywhere I used Plotly to have a better visualization. See, not Matplotlib. Plotly I used. Plotly. That's over. This is how we can use Arima. This is the code. Okay, fine. Okay, that's certainly an effort. And out of the context, that's not been included, but it's been asked to me, so I shared the details of the time series Amazon. And this is not a new project; it's an older project which I did.
Sir, it is possible to find the future prediction.
Yes, what?
Likewise, right now we are doing time series. It is
Haha,
possible to find the future prediction.
haha, future prediction. See, we can find the future
Can you
prediction.
can you show me how
I will
it is
share you the
done?
code. Okay, I will share you the code, Ajay, in which I have calculated the future prediction. Okay, and the
Sure.
concept will be the same. I will identify the last index of my series, and the future prediction will be okay. You want to find the next 10, so apply the model there. Okay, apply the model there and put this particular index. You will get the future prediction. Okay, and what I did in
Sure.
this, okay, what I did in this ARIMA for the prediction, I just gave the order. I gave the order. Okay, I trained my model and to predict, I just gave
Hmm?
start and the end. See, you can see, I just gave start and the end. So if you need to predict the future, your start will be the last index of your series plus one, and the end will be as many as you want. You understood what I'm trying to say? The start will be last index plus 1, and the end will be, for example, you want 10 predictions, next 10. So just add 10 here. Add 10 to this value. Okay. I will share the reference. If not, I will tell you from my side. So here I took start to length of the data frame. Instead, I will not take this thing. For example, the length of my data frame is how much? Length of my data frame is 1000. So now I will start from 1001. This is how I will start. And if you want 10 predictions only, so I will end with 1010. Okay, I will end with 1010. This will give you the future 10 predictions. Got it? This is how you have to do. I hope this makes a sense. Okay, Mr. Ajay.
Can you run and show the difference between the future and
Difference between?
it is like just
Huh?
showing the future prediction.
Huh?
It will be end with 1010, and
Huh?
can you show the difference like how it will be predicting the future
See,
prediction?
difference means what? Your
Like
model
in the
hmm,
yeah, in the capital representation.
in can you please tell loud what you are asking, Ajay?
Sir, actually we are predicting the future prediction.
Future, na.
Uh,
So future,
yeah,
that
yeah.
means that's what I'm saying, na. That
So
means
how,
if you have been asked that kindly tell what are the predictions for next 10 days. That's what I'm saying.
yes, 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 yes.
तो यही तो बता
So
रहा है
it is
वो.
possible to see that like
हाँ
right now we are seeing the uh, right now you are applying this.
हाँ
So
देखिए
can please
देखिए see understand. You have applied arima, that is auto regressive. Auto regressive means, let me share. Auto regressive means it understood the pattern by considering the previous values, the past values. That is how it has learned. So the trend which has been followed from the past, that is learned by arima, auto regressive. Okay, now you are saying that kindly tell me the next 10 days prediction. That is the future. I don't know. Today's date is 3rd October. Can you, sir, tell me what will be the price? What will be the price? Next 10 days price. till 10 October I want the price of Amazon stock. So I do have a data till here. I want to attach. See here you have to attach the next 10 days to the existing one. That is how we do apply in general. Okay, so for example, you are having 100 till here. You are having 100 till 3rd October. You are having a data from 4th October, 5th October, 6th October, 7, 8, 9, 10. You want. Okay, so in your Arima, that's what I told. Start from where? Start from 1001. That means till 1000 you are already having predictions. Now you have to start from 1001 and you have to end till 10,000, 1010. Next 10 days you have to predict. Got it? You try this thing. I will share this code with you. You try. And if you face any difficulty, you can let me know. Ajay. Got it?
Sir, sir, sir.
Okay, fine. You try then. I hope the other understood. They are listening to me and they understood that okay, the trend you have followed and the next trend you are putting now, so you can put that value into the model. Anyways, fine. So let me share the screen. That's what I did. So Yahoo का ही कर लेते हैं हम. Okay, let me stop the recording.